everyone, so welcome to my YouTube channel. So welcome to the world of chemistry. In that we are going to start with a one chapter that is very important and not easy, but I will make it easy. So we are going to start with a chapter name that is thermodynamics. Thermodynamics. Okay, I'm writing after a long time to bhaiya thoda. Okay. Thermodynamics. Thermodynamics. Okay. Don't worry about the handwriting and don't get shocked like, oh, sir is having that much good handwriting. Sir is having this much good handwriting. I don't have this much good handwriting. No, don't get confused with the handwriting. Okay. So adjust, manage the handwriting. Okay. Cholega bhai. So guys, what we are going to do is from now onwards, I am going to upload the video for the chemistry first year, means the 11th, and the second year 12th, 11th and 12th. Only NCERT based, not the J and NEET. Because I know if I will upload, you will not attend the class though. No. Okay. Very easy. Thermodynamics and thermochemistry will be in one chapter, that is a high weightage. Then equilibrium, in equilibrium, chemical equilibrium, then ionic equilibrium, weightage. And then organic chemistry, the organic chemistry also 4 or 5 topics, weightage chapter. So these are the very important things and very important chapters. So let's start. Okay, the first thing is what? First thing we'll see about thermodynamics. See, the understanding the concept is very important in place of by hurting the definition, by hurting the things. So understand, if you understand the concept for the chemistry, then for solving, like when you will go for solving the sums, it will become very easy peasy. Okay, otherwise if you will just by heart and then you will go for solving the sums, you cannot able to find like which formula you have to apply, whether it will be positive, negative. So moe will happen. Okay, and when you will go to like how you will get the playlist, nothing guys, just go to the playlist. There you will search the thermodynamics chapter, so in that thermodynamics will come. Okay, so the playlist for, if you like, next I will upload the equilibrium. So for equilibrium you will go to the playlist, you will see the equilibrium, you will get the equilibrium chapter. So you have to go to the playlist, you will get the chapter name. Okay, so we'll start with the thermodynamics. Thermodynamics means what? Thermodynamics is made up of 2 words. First is thermo, another is dynamics. All we know, it's easy peasy. Thermo means what? Heat. Whenever we talk about heat, we will say thermo. And dynamics, see, very important thing and very easy. There are 2 words, stationary and dynamic. So stationary means, from the name itself understand. Hey bhaiya, ore pagal. Stationary means, don't think that a stationary shop. Oh, a stationary shop. No. Stationary means which is at the rest. Okay. So first one is stationary, which is at the rest. Another one is dynamics, which is moving. Okay. So thermo means heat and dynamics means moving. This is not moving. This is stationary. Statue. This is dynamics, moving. Thermo means heat. Heat is moving. Okay. So thermo means what will happen? Thermo means heat. Dynamics means we can say flow or we can say movement. Okay. So that is thermodynamics. Okay. So guys, see, heat will flow. We will do the work. Work is what? Yes, work is being done. Okay. And then if you will talk about this thing, क्या बोलते हैं यार? Heat and work, right? Heat and work both is a type of energy. So heat and work, if we will talk about heat or if we will talk about work, that is nothing but both will come under the energy, right? Because heat will transfer, or heat will, like, you will release the heat or you will absorb the heat. So what energy is applying, right? and then another is work, for doing any work or work is done upon you. So for both the things energy is there. Okay, if suppose I am doing work on you, means I am beating, so I am beating, so what is it? I am applying my energy to beat you. And if you are beating if you are doing some work, so what is happening? You are applying energy. So for doing the work we require energy. And heat is also, heat will not generate normal, like you are sitting here, you are hot, heat is generating from your body like this. No, heat means you will do some work, like I will rub this, so heat will get generate, right? So what is I'm doing? I'm applying the energy here. So that's why heat or work, it requires the energy. So thermodynamics means what? Thermodynamics means, thermo means heat and dynamics means movement, the flow of heat. Okay, now if you talk about the like thermodynamics, see, the thermodynamics of the physics and the thermodynamics of chemistry is totally different. So don't get confused and don't relate both. Thermodynamics for physics, thermodynamics for chemistry, both are, you know, far apart, like how you and far apart. So if we'll talk about thermodynamics, so thermodynamics is what? First understand the thing, then important thing I will write it here. Okay, so then later on you can copy. First understand. So if we'll talk about thermodynamics, it is a branch of science which deals with how energy flow and changes within a system. Very important, guys. We don't care about the surroundings, but in life we care about the surrounding only, right? Oh, she's seeing ye bhai wo dekh raha hai. Okay, girls, if some boy is seeing, you are like, okay, a boy, if girls, some girls are watching, you are like okay, aesthetic. So what is this? Like in life we'll care about the surrounding, but here in thermodynamics is what? Is a branch of science which deals with how energy flows and changes within a system. So understand, we know, like we have already studied about the two things, system and surrounding. System and surrounding. So system is basically the things upon which we are observing. Okay, system means the things upon which we are observing, that is our system. Like you are observing now me, whatever I am doing Pakaiti, you are observing me. So what is this? I am your system. Okay, so that is the system. System means what? Upon which you are observing, that is the system. Understand the concept. If you understand the concept, the future topic will become easy and you can easily solve the problems. Otherwise you will like what happened? Okay, moe. So system means what? Yes, the things upon which we are observing, that will become the system, and except that all the things are surrounding. So here in thermodynamics we don't care about the surrounding, we just care about the system. Okay, so what is the thermodynamics is what? Thermodynamics is a branch of science which deals with how energy flows, how energy is flowing. Energy means either heat or work. Okay, so we'll talk about here heat or work. So how energy flows, and energy flows, first thing is what? Energy flows. Second thing is what? And changes within the system. And another important thing is, here in thermodynamics we will not deal with the microscopic level. No, microscopic means very chuttu sa level. We are not going to deal with the microscopic level, we are going to deal with the macroscopic level. Macroscopic level means big changes, volume is changing, enthalpy is changing, okay, entropy is changing, Gibbs energy is changing, okay, mass is changing, volume is changing. So that is what is called, that is called as macroscopic. So we'll not see the microscopic such cheez, will not see that, we'll see the macroscopic. Okay, so that is the how the like thermodynamics deals with. Okay, so here I will write it here. So thermodynamics means what? Thermodynamics is a branch of science. Thermodynamics is what? Thermodynamics is a branch of science. Don't get confused by the seeing handwriting, guys. Handwriting. But thermodynamics is a branch of science which deals thermodynamics is a branch of science which deals with what it will deals, yes, which deals with how energy flows, which deals with how energy flows. Very important thing, how energy flows, and yes, and changes within a system, and changes within a system, and changes within a system, changes within a system. So thermodynamics basically deals about the two things, means focus, not deals, focus about the two things. First thing is what? Branch. It is like branch of science. We know thermodynamics will come under physics, thermodynamics will come under chemistry. So physics and chemistry is a what? Branch of science. So thermodynamics is a branch of science which deals with how energy flows. How energy flows means, understand the thing, energy flows. So energy, suppose how energy, if I will talk about the heat energy, okay, if I will talk about the heat energy, so what will happen, if suppose I will bring a hot water, I will bring a hot water. So what will happen if I will keep the hot water here? So what will happen, from the hot water, the energy means heat, energy I am talking about heat. So the heat will flow from system to surrounding, the heat will flow from system to surrounding, the heat will flow from system to surrounding. Okay, another is what, if I will like in the hot summer day, we will fill a cold water in the bottle, but after, like when you will go outside after 2 or 3 hours, that cold water will become normal. Why? Because outside the surrounding is the heat, outside surrounding is heat, and the cold water is cold. So what will happen that time, the cold water will absorb the heat from the surrounding. So now this time what is happening, in this condition, the heat is transferring from surrounding to system, means the cold water bottle is absorbing the heat from the surroundings, and now the cold water will change into hot water. Okay, so these two condition, how energy flows, either it is flowing from system to surrounding, or it is flowing from surrounding to system. Two things will happen, how energy flows. Now the thing is, and changes within a system, So first condition, what the first condition, joldi joldi bolo re, joldi. Yes, the first condition is I bring the hot water. So hot water, now what is happening in the system, the system temperature is high. If I will bring the hot water, the system temperature is high and the surrounding temperature is low, Now how the energy flows, joldi bolo re bolo. Yes, the energy flows from system to surrounding, the energy is flowing from system to surrounding, means what is happening, now the surrounding temperature is increasing, and the system temperature is decreasing. So how energy flows, joldi bolo. How energy flows from system to surrounding. And what changes within a system, I don't care about the surrounding, whether surrounding temperature is increasing or decreasing, I don't care, just we have to focus within a system. So what is happening, the energy is flowing from system to the surrounding, energy is flowing, the hot water, that heat energy is flowing from system to surrounding. And what changes is happening within the system, yes, the temperature of the water within a system is decreasing. Right, when you will keep a hot water and keep the hot water for half an hour, what will happen, that hot water will become a normal water. Why? The energy flows, how the energy flows from system to surrounding, and what the change is happening within the system, the temperature cools down. And what is the second condition, you will take and go the hot water bottle in the cold water bottle in the hot summer. So what will happen here, energy flows from surrounding to system, the hot air will go to the cold bottle. So the system, the energy, how energy flows from surrounding to system, and what changes happening within the system, the hot Before it was, the hotness was very less. Now the hotness will increase and the cold water will become hot. So that is what the thermodynamics, heat flow from system to surrounding, from surrounding to system, system to surrounding, surrounding to system, and changes within a system. That's it, changes within a system. Okay, flow, energy flow and changes within a system. That's it, we don't care about the surrounding. And another thing, what I have told you, that we will, in the thermodynamics, we will not see about the microscopic level, we will see the macroscopic level. So microscopic level means, take the what you can say, take the second condition, cold water will take and go in a hot summer day. So what will happen, we know the hot temperature outside, it will make the cold water bottle also hot. But maybe in the microscopic level, what will happen, the water bottle, okay, the water inside the water bottle, it will become heat, and maybe it starts evaporating. Maybe starts evaporating. So that is the microscopic level, which we don't care. We are like, no, microscopic level, we don't care. We don't care about the water bubbles or the vapors which is going out. We just see the macroscopic level. What is the macroscopic level? Like, it absorbs the heat and the cold water bottle will become the hot. That's it, that is the macroscopic. We don't care about the microscopic. Okay, if you want to understand the good, because see here, from now onwards, whatever I am giving the example, with that example we are going to study all the basic concept of the thermodynamics. Okay, then we will move on for the first law of thermodynamics. Okay, so like, suppose you are with your favorite person, so now where you will, if you are moving with your favorite person, so what is happening here, where your observation, you will observe only your favorite person, so you are observing your favorite person, right? That for favorite person is saying something, you will be like observing your favorite person, so what is happening, that favorite person is the system. Okay, that favorite person is saying blah 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 and blah 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 blah, but you are observing. Okay, you are observing your favorite person. So what is happening, that favorite person is the system. Why? Because you are observing the favorite person. That favorite person is the system, and you don't care about the surrounding, right? When you are with your favorite person, the background music will be playing, you don't care about the surrounding, hand in hand you will be walking. So what is happening, you are talking, you are observing, right? You are enjoying the moment. So that time all focus on the favorite person. So that time favorite person is what, favorite person is the observing thing, you will observe. So that time the favorite person is the system and everything is surrounding. And when you are in thermodynamics states, we only care about the system, we don't care about the surroundings, right? Yes. And what will happen, thermodynamics, okay, that is the system and that is the surrounding. And next thing is, what the thermodynamics deals with, only system. When you are in thermodynamics states, you will only focus the system, your favorite person, you will forget about the surroundings. So the thermodynamics do the same thing. And what will happen, when you are with your system, you will hold the hand. So when you will hold the hand, what is happening, the energy will flow, right? The energy will flow, the positive vibe will flow, all the stress will go, right? In life you will say 100 problems but one solutions, right? You are the one solution, holding hand. तुम ही हो मेरी जिंदगी अब तुम ही हो. So that only, when you will hold the hand, what is happening, energy flows. So energy flow maybe from that hand to, maybe from your favorite person hand to your body, or from your hand to favorite person body. So energy flows. And what you will say, changes within a system. Changes within a system means you will only focus Your favorite person changes. Yes, the favorite person changes. The mood is becoming happy. That favorite person is blushing. That favorite person is shying. So what is this? This is the how energy flows and changes within a system. You don't care about the surrounding, only within a system. Okay. And changes, the microscopic changes we don't care. Microscopic changes means the heartbeat will become fast, butterflies in the stomach. We don't care about that. We will only see the macroscopic, right? Happiness, blushing, doing a childish behavior. So that is the thermodynamics. How energy flows and changes within a system, only of the macroscopic, not the microscopic. Okay. And this is the first thing. Second thing is the classical thermodynamics. The classical I will teach you this much better. Why it will become perfect. Baba, perfect. Okay. The classical thermodynamics. The classical thermodynamics law. See, if we'll talk, why I'm saying the classical thermodynamics law means this law only the thermodynamics follows. The classical thermodynamics law are mostly are most sorry not mostly most are most directly understand the thing. The classical thermodynamics laws are most directly applicable most directly applicable to the systems, understand, to the systems that are either in equilibrium, that are either in equilibrium that are either in equilibrium or change in a way or change in a way such that or change in a way such that such that such that such that it moves from one equilibrium it moves from one equilibrium state to another. It moves from one equilibrium state to another. Okay, this is the classical thermodynamics law. This is the classical thermodynamics law. The classical thermodynamics law, what it says, are most directly applicable. Where it is directly applicable? To the system that are either in equilibrium or in change. How? In a way such that it moves from one equilibrium state to another. Okay. So what is happening? If we talk about the thermodynamics means heat can flow or heat can absorb. So that's why they say the classical thermodynamics law is what? Most directly applicable to the system that are either in equilibrium. System is in equilibrium means the same heat is flowing, same heat is absorbing. Either system is in equilibrium, or if suppose change is also happening, means it moves from one equilibrium state to another equilibrium state, but it should be in equilibrium. Either it should be in equilibrium or it is changing from one state to another state, but it should be in equilibrium only. Okay, like how as we are talking about thermodynamics state, like you both are going, or you and your favorite person are moving, enjoying the time. So this thermodynamics movement happening, right? The energy flows, right? Energy flows either from your your system to you or from you to your system. Okay, and changes within a system. You don't care about the surrounding. But this classical thermodynamics law, when only it is applicable? When both are in love with each other. So that's why both are in love with each other, both are loving each other. then only it will be a equilibrium. You are how much you are loving and giving effort to that person, that person is also loving and giving effort to you. So that's why it is in equilibrium condition. It should be in equilibrium condition, right? So that's why when you will hold, the energy flows and the change will happen within a system. Otherwise no change will happen in the system. When both love, means equilibrium will not be there, then system will be like normally, अरे यार हाँ चलो 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 ठीक है, okay, you're not giving the enough time, chalo 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 theek hai. And then your focus will also be not be in the system, your focus is like somewhere in the surroundings. Okay, so what we want that either in equilibrium, both are in love, totally deep love, or change in it move from one equilibrium state to another equilibrium. Means it move from one equilibrium state to another equilibrium state, means when first condition is when you both are loving each other, true wala love. Or second condition is what, when suppose you both meet newly and you are falling in love, means it moved from one equilibrium state to another equilibrium state. You was having before, you both were having before, breakup happened, but now you both are falling. You means that person was having someone else, you was having someone else, you both were in the equilibrium state, done, break the bond breakage happened, now you both are falling for each other. So from one equilibrium state to another equilibrium state. So thermodynamics. So that is the thermodynamics they talks about. Okay, now what will happen in thermodynamics? First thing is system. Okay, this is the definitions you can write. Okay, now first thing is system. Okay, definition of system I will tell you, you can write down. Definition of system means a system in thermodynamics refers to the part of universe under observation. Part of universe, very important thing. Okay, चलो लिख लो, लिख ही देते हैं भाई तुम लोग के लिए. A system is in thermodynamics. A system in thermodynamics. A system in thermodynamics refers to the, a system in the thermodynamics refers to the part of universe, refers to the part of universe under observation, part of universe under observations. Okay, see, this is the like proper definition I'm giving you. So system in thermodynamics refers to the part of universe. Why? Because we know system plus surrounding, system plus surrounding equals to universe. It will happen in thermodynamics, system, and then you will add all the surrounding, that is system plus surrounding equals to universe. So system is what? A system in thermodynamics refers to the part of universe under observation. Suppose your favorite person, when you will see the favorite person, what you will sing a song, मैं अगर कहूँ तुम सा हंसी कायनात में है ही नहीं. Kayanat is nothing but a part of universe. So your favorite person is also a part of universe. So your favorite person is a part of universe, and that favorite person is under observation of you. So that is the system. The system in thermodynamics refers to the part of universe under observation. So your favorite person is also a part of universe. 1,000 lakhs of universe girls in the universe, but you are focusing, right? So that way it is a part of universe under observation. So that is a system. Okay, next we will see the surroundings. Surroundings means what? Surrounding means लिख लो, part of universe other than system. So part of universe other than system, that is all surrounding. Okay, now guys, universe. Now universe means system and surrounding together makes universe. System plus surroundings, system plus surroundings will make the universe. System plus surrounding will make the universe. Okay, Now next thing we'll talk about, the important thing is the boundary. Boundary is nothing but, suppose if I will take this a beaker, if I will take this beaker, okay, if I will take this beaker, in this beaker if I will fill the water, in this beaker if I will fill the water, in this beaker if I will fill the water. So now I am observing this water, I am observing this water. So if I am observing this water, so this water is our system. Other than water, whatever the things outside, that is surroundings, that is surroundings. So what will happen? System and surrounding is separated by this beaker. System and surrounding is separated by this beaker. So this beaker is what? This beaker is the boundary. This beaker is the boundary, or we can call it as a wall. Boundary or wall which separates the system from the surrounding, which separate the system from the surrounding. That is a boundary. Like if you are moving with your favorite person, then you are saving your favorite person from the surrounding. Then your favorite person is what jaldi bolo bhaiya. Your favorite person is the system, your favorite person is system, and you are guiding, you are supporting, not guiding, you are supporting your favorite person from the surrounding, कि कोई दूसरा लड़का टच नहीं करे, no one will see her. तो समझ रहे? तो your what you are means your favorite person is the system, you are what you are protecting that system from the surrounding, means you are making separate your system from the surrounding. So that is the wall, you are the wall. So your system and you are the wall, other all the thing is what? Surrounding. So you are protecting your system from the surrounding. So that is the boundary or wall. So boundary or wall means which separate the system from the surrounding. So you are separating your system from the surrounding, like no one should have to touch you, no one should have to do anything. Okay, now when we'll talk about, wait a minute, when we talk about the boundary, okay, boundary or wall, so there are two types of boundary, you can say, or there are two types of wall. There are two types of boundary, or there are two types of wall. Okay, first is what? First is adiabatic wall. Adiabatic wall or adiabatic boundary. Okay, second is what? Second is, yes, diathermic. Second is diathermic wall or diathermic boundary. So see, understand, very important thing. Whenever we talk about the wall, okay, what I am eating? Apple. I will tell you one story of apple. We all say an apple keeps the doctors away. An apple a day keeps the doctors away, right? An apple a day keeps the doctor away. I will tell you. My favorite person was doctor. I was eating the apple. An apple a day, doctors away. Focus करो, जल्दी देखो. Okay. Adiabatic wall. The first thing is what? Whenever we talk about adiabatic wall, guys, understand one thing. Adiabatic wall means whenever we talk about adiabatic wall, heat transfer is zero. Okay, it will not allow the heat to transfer. Okay, it will not allow the heat to transfer, but matter, okay, heat means what? I'm talking about energy. It will not allow the heat to transfer. Okay, it will not allow the heat to transfer. But if we talk about the matter exchange can happen. This is very important thing, understand, for the adiabatic wall. If someone is talking about adiabatic wall, means heat equals, means heat transfer. heat transfer equals 0, means there is no heat transfer. You can write heat transfer equals 0, you can write no heat transfer. Adiabatic wall means it will not allow the heat to transfer, it will not allow the heat to transfer, but matter exchange is possible, Adiabatic wall, suppose your favorite person and you are here, okay, as a wall. So heat exchange will not possible. Heat exchange will not possible means you will not allow the other person to touch your favorite person. So that's why heat will flow by touching, right? By holding, heat will flow. So adiabatic wall means it will not allow the heat to flow. No, heat will not flow. You should not, means you can't touch. Heat will not flow. But matter exchange means if you want, if your favorite person wants to exchange something like notes, the books, okay, or anything, if they want to exchange, they can exchange. So matter exchange can possible, but heat transfer is 0. You are like no one can able to touch. When you become adiabatic wall, you are like no one can able to touch. No, you are like red flag. No one can able to touch. No. So heat transfer is 0 because touching only, then only heat will transfer, right? So no touching and all. So heat transfer is 0, but matter can exchange. They can share the things, notebook, pencil, pen. So matter exchange is possible. So this is what this is, no heat transfer. Okay. So what is this? This system is isolated wall. So adiabatic wall is also known as isolated wall. Okay, isolated wall because no heat transfer. No heat transfer. So no heat transfer means what will happen? No heat transfer means what? No energy, right? No heat transfer means no energy because heat and work will come under energy. No heat transfer means no energy transfer, right? No heat transfer means no energy transfer, but matter exchanges can possible. They can share the apples. Doctor. Okay, so they can share the things. Okay, the matter exchange can possible, but heat transfer 0 means no heat transfer. No heat transfer means no energy transfer. Okay, no heat transfer means no energy transfer. Okay, now diathermic wall. So adiabatic wall is nothing but like a red flag. If you are meeting with your bestie also, be far, no handshake, just hi, hello, that's it. You want to give anything, give. You want to take anything, take. Matter can exchange, but heat transfer and no energy transfer. Red flag. But when we talk about diathermic wall allow heat transfer. Diathermic is green flag. Bhaiya, in exam don't write and allocate diathermic wall is also known as green flag. मारेंगे हम टीचर लोग ना बकैती करेगा वहाँ तो. Allow heat transfer. Diathermic wall is what? Allow heat transfer. Okay. Allow heat transfer. So diathermic is a green flag. Okay, fine. If you want to meet with your bestie, you can shake your hand. You can do side hugs and all. Okay. You can sit. You can you can do like this and all. So allow heat transfer. Allow heat transfer means it will allow the matter also exchange. Okay, matter can also exchange. Okay, so heat transfer adiabatic wall means no heat transfer. The best example wait. So okay, adiabatic wall means isolated wall where heat transfer is not possible. Like suppose I will tell you, like a thermo flask. If you will take the thermo flask, the bottle, in which if you will keep the hot water, inside it will be hot. If you will keep the cold water, inside it will be cold. But if you will touch from outside, you can't feel that inside hot or cold is there. You will feel that okay, just a normal water bottle. Okay, you cannot able to get to know inside whether it is hot or cold. So that's why no heat is transferring. If it is hot water, it will be remain hot. If it is cold water, it will remain cold. So if you will touch outside from, if you will touch from outside also, you cannot able to get to know like what is the temperature of the water inside, either hot or cold. So that is adiabatic wall. It will not allow the heat transfer, isolated wall. But matter can exchange. You can open the water bottle, you can take the water, you can fill the water. So matter exchange is possible, but heat transfer no. Diathermic, so that's why adiabatic is isolated one. Diathermic wall means the normal water bottle. If you will fill the water, it is hot. When you will touch, you will feel it hot. So heat is transferring. Okay. And what? Yes. If you will feel the cold water, if you will touch, you will feel the cold thing. So heat is allow heat transfer. So that is the diathermic wall. Okay. So this is the two things. Okay. So here the mostly we will say this is isolated wall. Here we will say metal wall, because metal will allow the heat to transfer easily. Okay, fine. So next we will see the types of systems. Okay, so first we understand about thermodynamics, then definition of thermodynamics, then classical thermodynamics law. Okay, then after that what is system, what is surrounding, what is universe, then boundary, and then types of boundary, adiabatic wall, diathermic wall. Now we will see about types of systems. Now we will see about types of systems. Types of systems. Okay, types of system. Types of system. The first type is what? First type is open system. First type is open system. First type is open system. See, open system we know if the system is open. Open system means the system is open. So we know if the system is open means what will happen? Okay, wait. Okay, if the system is open, but we have to see the wall. See, open system, closed system, isolated system we have studied, but all the things depend upon the wall. If suppose here system is open and it is okay, no. No. Types of system, like it does not depend upon the wall and all. Okay, types of system, no. Types of system is open system. The one thing I have to explain you later, I will explain. So types of system is open system. If system is open, then easily heat can transfer. The hot water can transfer. The like hotness of the water, the heat energy can transfer, or they can take the heat. So if the system is open means which type of wall? Diathermic wall. If the system is open means it is diathermic wall. System is open, diathermic wall, because it will allow the okay. So this type, okay. Now wait, I will explain you. Okay, system is open and we have a diathermic wall. Okay, system is open and if we have a diathermic wall, so what will happen here? Open system and diathermic wall. So from wall what will happen? The heat can able to transfer. See, everything we talk about, guys, for every system we talk about the two transfer: heat transfer, matter transfer. Means matter exchange, not transfer, matter exchange. Two things will happen. What? Heat transfer, matter exchange. Heat transfer, matter exchange. Okay, for any type of system, that only I was about to tell you. This is my wall ka differentiate. Okay, so guys, for any type of thing, for types of system, we want the two things. What? Heat transfer, and one more thing is matter exchange. Heat transfer and matter exchange. Okay, now if I will take a type of system is open system, and in open system if I will take this wall, adiabatic wall. If it is open system but I will take adiabatic wall, so what will happen? Heat transfer got stopped. Guys, adiabatic wall means it is isolated wall. The heat transfer will get stopped, but only if it is open system, the matter exchange can be possible. Okay, open system, if I am using adiabatic wall, So adiabatic wall means isolated wall, no heat transfer. But matter exchange can happen because it is open. Matter exchange can happen. So the main thing is, if I will take open system with diathermic wall, open system with diathermic wall. Diathermic is what? Yes, diathermic is a green flag. Bhai, diathermic is a green flag. So what will happen? I have taken the open system with diathermic wall. So diathermic wall, what it will do? It will allow the heat to transfer and it will allow the matter exchange also. So what will happen? Types of system, only two things we will see: heat transfer and matter exchange. The open system, if I will take adiabatic wall. Okay, red signal. Sorry, red flag. Adiabatic wall, red flag. So guys, you have to write. I will not write that. You can write. Open system adiabatic wall means what? Open system adiabatic wall means no heat transfer. No heat transfer. Why? Because adiabatic wall is an isolated wall. Red flag. No heat transfer. No. But yes, matter transfer. Yes, matter exchange. Not sorry, transfer. Matter exchange. But if I will take open system with diathermic wall is green flag. You can meet, you can handshake and all. So what will happen? Heat transfer is possible. Heat transfer is possible. And what will happen? The matter exchange. Obviously, matter exchange is also possible. Matter exchange is also possible. Heat transfer is also possible. Okay. Now second type of wall I will take is closed system. Sorry, second type of system is closed system. Now guys, again with closed system I will take, suppose if I will take a adiabatic wall. With closed system, if I will take a adiabatic wall. Okay, handwriting guys, I know, don't worry about that. I'm writing after 2 months in this pen and this pad. I have to write it here. Okay, so it is happening like this, but don't worry about that. From next 2 videos it will be proper. Okay, so okay, now next is closed system adiabatic wall. If system is closed and wall is adiabatic, so what will happen? With the wall, no heat transfer. Adiabatic wall means what will happen? In adiabatic wall, no heat transfer, and system is already closed, so no heat exchange also. Sorry, no matter exchange also. No matter exchange. But same if I will take the closed system is this, and same if I will take what? Diathermic, the green flag. Diathermic wall. Diathermic wall means yes. See, it is closed, but diathermic wall means the heat transfer is possible. Because wall is diathermic, but system is closed. If system is closed, then matter exchange is not possible. No matter exchange. Then matter exchange is not possible. Matter exchange is not, because system is closed, the bottle is closed. Matter exchange is not possible. But yes, diathermic wall means heat can able to transfer. Adiabatic wall means, obviously we know wall is adiabatic, so heat transfer is not possible. And closed system, so matter exchange is also not possible. Okay. And next, third one is isolated system. Okay, chalo. Guys, it is already isolated system. The isolated system means we cannot able to take the diathermic wall. Isolated system means system itself is a red flag. Obviously you are also the red flag, so we can't take the green flag. So system already a red flag. If you will be also a green flag, the system is not going to touch or not going to do the heat transfer, not going to do the matter exchange. No, nothing. System is only red flag. So isolated system, if system is isolated, then obviously we are going to use the wall is Adiabatic wall. We are going to use the wall is adiabatic wall. The adiabatic wall means bhaiya no heat transfer. No heat transfer, no matter exchange re baba. System is only red flag. You now your work is not there. If you are red flag, you will not allow the heat exchange, but you can allow the matter exchange. Okay, but if you are a green flag, you will allow the heat exchange also and matter exchange too possible. But system here itself is a red flag, means that system is only not the system here. The red flag means the adiabatic wall will come. No heat transfer, no matter exchange. Okay. Okay, now I want to give you one thing. Okay, adiabatic and then closed. Okay, this with adiabatic and closed system means no heat transfer, no matter exchange. But adiabatic, okay. Now very important thing. Chalo, I will tell you that one in the note. Okay. Now I will take the another one. Okay. Now the next one is next the fourth one is see, third one is isolated system. Fourth one is types of system is adiabatic system. Now system is adiabatic system. Adiabatic system is adiabatic system. Understand guys, this is the special case. System is adiabatic system and wall is also adiabatic wall. System is adiabatic system and wall is also adiabatic wall. Now understand one thing. System is adiabatic and wall is also adiabatic. So guys, we know whenever the adiabatic will come means what will happen? No heat transfer. Whenever the adiabatic will come, we know no heat transfer. Whenever adiabatic will come, no heat transfer. Okay. And next thing is what? Matter exchange is possible. Matter exchange is possible because adiabatic means what? No heat transfer, no touching and all, but you can exchange your like books, notes, that you can exchange. So matter exchange is possible. Matter exchange is possible. The adiabatic system and adiabatic wall. Adiabatic system and adiabatic wall. So adiabatic, whenever the adiabatic will come, no heat exchange, no touching, no heat exchange, but matter exchange is possible. No heat transfer, but matter exchange is possible. Okay. Now I'll give you one homework as a homework. Just try and just comment it. Okay. If adiabatic wall, if it is no, adiabatic wall. Okay. Adiabatic wall and okay, नहीं adiabatic wall. Okay, एक ले लेते ये adiabatic system, sorry, wall not adiabatic system. Guys, you have to tell me the answer in the comment box. Okay, adiabatic system and diathermic wall. चलो भैया, adiabatic system and diathermic wall. Adiabatic system and diathermic wall. Now you have to tell me what will happen to the heat transfer and what will happen to the matter exchange. You have to comment and tell me. Okay. Now we are going to see about the types of properties. So types of properties, we all know this is very easy peasy. Types of properties, there are two types of properties. First is intensive properties. Second is extensive properties. First is intensive properties, second is extensive properties. Okay. Now intensive properties, extensive properties, whenever we will talk, we will see the whether it is dependent or independent. So whether it is dependent or independent upon what? Upon amount amount of substance, amount of substance or size of system, or size of system. So whenever we talk about the types of properties, either intensive properties or extensive properties, we will see upon this whether it is dependent upon the amount of system or size of system, or whether it is independent upon the amount of system or size of system. Okay, so whenever we talk about the types of properties, either it will be intensive properties or extensive properties. Okay, the types of system is either intensive properties or extensive properties. So intensive and extensive, just we will see that whether they are dependent or independent upon what, upon amount of substance or size of systems, whether they are dependent upon amount of system or whether they are independent upon amount of system. Okay, so this is a very simple trick I will tell you, you will understand. Intensive property, the name itself indicate this. Int means introvert. Int means introvert, not int means I am giving you. How you can remember? From int we can make introvert. Introvert means what? It will not share the things. It will be themselves only. They will be with themselves only. They will not talk. They will not share the things and all. So introvert means independent. Independent. Introvert means it is independent upon other. Okay, introvert means they will be depending upon each other, just they will talk with each other only, they will be in themselves only, introvert. So that's why intensive properties means, you can remember from int means introvert. So intensive properties means introvert, independent of amount of substance or independent of size of system. But when we'll talk about extensive, from here we will get to know extrovert. Here you will get to know extrovert. Extrovert means, you know, they will be mingle, they will be depending upon each other. So extrovert means dependent. So extrovert is what? Extrovert means dependent. The intensive property means which is dependent upon the amount of substance or size of system. Okay, you can write the definition. Now intensive properties are those properties which does not depend, like temperature. Okay, suppose this room is having temperature of 27 degrees. If I will suppose, like, if I will bring a AC, okay, and I will fix in a one room, small room, and the AC temperature I will keep 27 degrees Celsius. Okay, so room temperature is what, 27 degrees Celsius. If I will bring the same AC to the big hall and AC temperature is same 27 degrees Celsius, so what will happen in the hall? The same temperature, 27 degrees Celsius temperature will go. So what is happening? Temperature is intensive property, it does not depend. Okay, same like pH. If suppose I will take the pH of like one acid, pH of one acid is I will take 8. pH of one acid is 8. From that I will take a 1 glass of acid. So what will be the pH of this acid? 8. Right? pH of this beaker, suppose this is the beaker, inside this beaker I will fill one concentration, I will fill the, like, suppose, you know, base, let base. So pH of that base is 8. I will take a 1 glass of base. So what will happen? Still here, the whatever the concentration is here, whatever the concentration will be here, its pH will remain 8, and whatever the concentration will here, its pH will remain 8. So pH will not depend upon the whether it is less concentration, high concentration, medium concentration. pH will not depend, right? So that is what intensive property does not depend upon it. It will remain same. Okay. Then like pressure. If I am applying the pressure upon the gas, okay, if the gas is less, if I am applying the pressure of suppose 20 what I can say 20 Newton meter, if I will apply the pressure of 20 Newton per meter, okay, pressure is what, force upon area. So if I will apply the 20 Newton per meter pressure, or if I will apply the pressure of 20 bar, suppose pressure of 20 bar, this much area, if I will apply the pressure of 20 bar, and this much area, if I will apply the pressure of 20 bar, so what will happen? The pressure will remain same. Okay, so what will happen? Intensive properties means the which is independent, but extensive properties means suppose volume. Okay, volume. Now what will happen? If I will suppose, if I will take a like suppose I will give one example for the intensive extensive, both you will understand. Suppose if I will take a one beaker. Okay, this is a one beaker, this is a another beaker. Okay, beaker A, beaker B. In this I have suppose one acid, and this also I have a one acid. Okay, this acid pH is 5. This acid pH is what? 5. This acid also pH is 5. This acid also pH is 5. But here this acid is 2 liter. Here the acid is 3 liter. Okay, now what I will do, I will take a big beaker and this both acid I am going to mix here. This both acid I am going to mix here. This both acid I am going to mix here. This both acid I am going to mix here. Now what will happen here? This acid was having the pH of 5. This acid was also having the pH of 5. So when I will mix this, so what will the pH of this acid? The pH of this acid will remain same as 5. It is not like the pH of 5 I am mixing and then the pH of 5 I am mixing, the pH will become 10. No. pH will not increase. The pH of this acid is 5. The pH of this acid, if I will mix this, the pH will remain as 5 only. But if we'll talk about the volume, so this is what? 2 liter and this is what? 3 liter. So 2 liter plus 3 liter, it will become 5 liter. So what is happening? pH will remain same, intensive property, but volume is adding, extensive property. So that is the intensive property, extensive property, guys. So your homework is this. I have already written the definition. You can write the definition from here. Intensive properties, which is independent of amount of substances or size of particles. Then example, you can write the 3-4 examples from the Google. Then extensive property, which is dependent upon the amount of substance or a size of system. The example you can write from the Google. Okay, now one more thing is there. Intensive properties, one more thing is there. Intensive properties means it will remain same. Intensive properties, what we have seen here, pH is the intensive property. So here also 5 pH, here also 5 pH, here will also 5 pH. So intensive property is what? Intensive property is non-additive. They will not add. Why? Because it is independent, introvert. They will not mix, so they will not add. Okay, so 5 pH of this acid and 5 pH of this acid, when they will mix also, the pH will remain same as 5. When they will mix also, the pH will remain same as a 5. Okay, so that's why it is non-additive. They will not get add. Now, but here, extensive property. This is a 2 liter volume and this is a 3 liter volume. So after adding here, it will become 5 liter volume. So what is happening? Volume is extensive properties. So if you will add, the volume will increase. The extensive properties is additive and intensive property is non-additive. Because intensive is introvert, they will not mix, they will not mingle. So not mix, not mingle means they will not add. So non-additive. But extensive is extrovert, they will mingle, they will add, they will make friend. So it is additive properties. Okay. And next thing is this, the important thing is, see here, if I will tell you density of water. Okay, if I will tell you density of water, so density of water is what? 1, right? Density of water is what? 1. If you will take 1 kiloliter of water, 2 liter of water, 3 liter of water, density of water will remain same as a 1. So density is what? Density is not adding, but volume is adding. If I will take 1 liter of volume of 1 liter, then volume of 2 liter, volume of 3 liter, volume of 4 liter. So what is happening? Volume is increasing, but the density of water will remain same. The density formula is what? Yes, density formula is mass by volume. Right, density formula is what? Density is mass by volume. So now you can see mass is also additive properties. When you will keep on adding the mass will increase. So mass is additive property. Additive means what? Extensive. So extensive property divided by volume is also what? Volume is also keep on increasing. The volume is also additive. The volume is also extensive. But what will happen? Density is intensive. Density is not going to change, as density of every liquid is fixed. Density of water is 1, density of other So density what? Density will remain fixed. So density is what? Density is intensive property. Density of every liquid is fixed. Either you take 1 volume, 2 volume, 3 volume, 10 volume, 20 volume. Density of every liquid will remain fixed. It is not going to change. So what we will see here? Density is what? Mass by volume. So if you will see the ratio of what you will write here, see what you will write here, ratio of two extensive properties will give intensive properties. Very important thing, understand. The ratio of two extensive property will give the intensive property. Density equals mass by volume. Mass is also extensive, volume is also extensive, but what we will get? Density. So it is intensive. The ratio of two extensive properties will give the intensive property. Okay. So these are the things what I have said you, like intensive properties non-additive, extensive properties additive. So please write on here point by point. You can write 2 to 3 point here. Okay, first the definition for both, second is this for both, third is this intensive property. Okay, third point you can write, oh third point you can write example, and this you can write in note. Okay, the ratio of two extensive properties will give the intensive property. And now guys, suppose if I will talk about mass. Mass is what? Extensive property. Mole is what? Extensive property. Volume is what? Extensive property, because it will keep on changing. But before them, if I will use the word specific, like a specific mass, a specific volume, a specific mole. So specific means what? Yes, the word itself indicates. The word itself indicates a specific means we should have to specified. Expensive. A specific means it is specified. We can't change it. Specific means it is specified. Already it is specified. We cannot able to change it. So if we cannot able to change it, means we cannot able to add or increase it, or it cannot able to change, means it is intensive property. So if I will talk about mass is extensive, volume extensive, mole extensive, right? But if you will talk about a specific, like specific mass, specific volume, specific mole, the word came specific means it is specified, so it is intensive. Okay, so the word this specific will come means it is intensive. Specific mass, intensive. Specific volume, intensive, because it is specified. But if I will say simple mass, simple volume, it is extensive. Okay, now I will give you one homework. Just you have to write the difference between state function and path function. Difference between a state function and path function. Difference between a state function and path function. Okay, state function, path function. Just read about this state function and path function, and this is your homework. Okay, so homework is this: state function, path function. Homework is this: to write the example of this intensive properties, extensive properties. This two homework and this one more homework. Like if I will take the adiabatic system and diathermic wall. So this homework you have to comment. This homework you have to comment. If I will take the adiabatic system and diathermic wall, what will happen to the heat and what will happen to the what? Yes, what will happen to the heat exchange and what will happen to the matter transfer. This example you have to tell, means you have to comment. Another example already you can search from the Google and you will get it, so you can write. Other homework, sorry, this homework you have to explain, you have to just comment in the comment box. Okay, so next class I will first tell this homework answer, then we will move on. Okay, so adiabatic system and diathermic wall. So what will happen to the matter heat transfer and what will happen to the matter exchange? Okay, comment in the comment box, and if you feel it good and if you're understanding, just like it, so I will get to know. And you can share with your friends. And subscribe madi. Okay, and do subscribe sir guys, subscribe. Okay, do subscribe. So state function and path function, just read it as a homework. Okay, so that's it for the introduction about the thermodynamics. Next class we are going to continue with the first law of thermodynamics. The state function means we know guys, which directly depends upon the state, like one state to another state, like solid to gas, gas to liquid. or liquid to solid. So it just depend upon the state, final state, initial, final, initial, final. That's it. It does not depend upon the path, like how the solid is converting into liquid, how the liquid is converting into gas. We don't care about the path. Like solid to gas is sublimation. We don't care about the sublimation process and all. Just we want the solid, final is gas. So that's why state function we will write like this. If I will write the delta T, means state function means final temperature minus initial temperature. This is state function. We just see the final temperature value, we will just see the initial temperature value, we will minus it, we will get the change in temperature. Same. Okay, so what is this? This means same. If I will take the velocity, change in velocity, so final velocity value minus initial velocity, so final velocity value minus initial velocity, so that we will see the change in velocity. We don't care how the final temperature it changes and all, and how we will get the initial temperature. We don't focus on the path, we just see the final state, initial state, the state function. Okay, now path function means what? Path function obviously depends upon the path. It does not depend upon the direct initial and direct final. It depends upon the path, how the initial is changing into the final, like solid to gas. So solid to gas, so this is what I am seeing, the solid gas, solid gas. Just I am focusing on the state, so that is state function. If you will see about solid to gas means sublimation process. So sublimation process, so we'll focus on the process, so that is called path function. Okay, so the state function is what? Path independent. Path function is path dependent. Okay, so state function and path function means I will give you one direct example. If you are on the third floor, I will tell that we have to reach to the ground floor. The state function means from first floor we are reaching to ground floor. That's it. I said from first floor you have to, sorry, from third floor we have to reach to ground floor. So our main aim for state function, from third floor to ground floor. However you reach, it's your. You can take the stair, you can take the lift, or you can jump. So that is the state function. We don't care about the path. But from third floor you have to reach to the ground floor. That's it. But path function means I will tell you, from third floor to first ground floor you have to reach to the through stairs, or you have to reach to through, like, you know, lift, or you have to jump and reach. Okay, or you have to use the rope and you will reach. So that we will see that how you reached, by which path you have used, by the rope, by jumping, by stairs, by lift. So that is the path function. So this is for the today's class, and this is for the introduction about the thermodynamics. And now in the next class we'll continue about the first law of thermodynamics. So first we'll complete all these things, and I'm giving you the notes, I'm dictating you the notes, and I'm telling you how to write it, so you can write the notes. Okay, so thank you, bye bye, we'll meet in the next video.